All right, guys, so now we're going to tackle actually multiplying two matrices together, and this is way different. You don't multiply element by element. You're actually going to have to do row column multiplication. Some really interesting things are going to happen, and some things have to actually be set up a certain way. All right, so the first thing we're going to do is we're going to walk through and talk about A times B. The first thing you're going to have to do is you're going to have to evaluate the order of these. Well, matrix A is a 2 by 2. There's 2 rows and 2 columns. And matrix B is by a 2 by 3. There's 2 rows and 3 columns. Here's what we have to look at first before we multiply. You want to put the orders next to each other. A 2 by 2 and a 2 by 3. These numbers right here, your interior numbers, they must match. If they don't match, you cannot multiply these matrices together. But if they do match, our result, our answer is going to be a matrix of my outside numbers. So I know A times B, when I'm finished with it, will have an order of 2 rows by 3 columns. Interesting enough, if there is any meaning attached, this is going to be the meaning from A1. Well, meaning of matrix A. Of course, that's the row meaning. And then this right here is going to be your column meaning of matrix B. Y'all know I can't spell. That's going to be important as we get into actually applying matrix multiplication into problems, because we have quite a few real life examples we're going to have to do, and then you're going to do a major grade. And the major grade is going to be where you're going to be figuring out what type of combination from a recipe is going to give you the most protein, carbohydrates, fats, things along those lines from the nutritional tags from actual food products. All right, so right off the bat, we see that we can multiply AB, but let's take a look and see, can we do B times A? Well, B is a 2 by 3, and then A is a 2 by 3. Well, if you see right here, these numbers don't match, so this does not exist. Well, that's kind of weird because everything we've done before with multiplication, it's actually commutative. A times B would give us a number, and then B times A would give us the exact same number. But commutative property in matrices, they just don't get along. Multiplication of matrices is not commutative, so you have to understand that. So it's actually really important to understand, even if you're left multiplying by a matrix, if you want to move it to the other side of the equal sign, you still need to left multiply. It's not where you can put it wherever you want to anymore. You have to pay very close attention. So let's actually calculate A times B here. So we have a matrix. We have my matrix A, which is A sub 1, 1, A sub 1, 2, A sub 2, 1, and A sub 2, 2. And we want to multiply it by B sub 1, 1, B sub 1, 2, B sub 1, 3, times B sub 2, 1, B sub 2, 2, and B sub 2, 3. Okay, so here's what we're going to do. What we do is we're going to multiply this first row. We're going to multiply A sub 1, 1 by B sub 1, 1, and then we're going to add it to A sub 1, 2 times B sub 2, 1. A lot of fun. So here we go. My new matrix is going to be A sub 1, 1 times B sub 1, 1 plus A sub 1, 2 times B sub 2, 1. Take a moment and look here at your middle terms, 1 and 1, 1, and then your outside terms, 2 and 2. We'll see your inside terms are matching. If you do it right, it should match up all the way across. Wait, sorry, that's not true. I don't know what I was thinking. All right, let's do the next column. We're going to have A sub 1, 1, A sub 1, 1 times B sub 1, 2 times a sub 1 plus a sub 1, 2 times b sub 2, 2. All right, I got to move this. I don't have enough room. Now I should have enough room. Now we're going to do this still the first row with the last column. So we're going to have a sub 1, 1 times b sub 1, 3 plus a sub 1, 2 times b sub 2, 3. All right, so that row's done. Let's go down to the second row. We have to do each row multiplied by each column. So we are going to be doing this row now by each one of these columns to get my new matrix. So here we go. We're doing a sub 2, 1 times b sub 2, 1 plus a sub 2, 2 times b sub 2, 1. Then we're doing a sub 2, 1 times b sub 1, 2 plus a sub 2, 2 times b sub 2, 2. Last column, first row, or second row, third column. Finish up my last term here. It's going to be a sub 2, 1 times b sub 1, 3 plus a sub 2, 2 times b sub 2, 3. And of course, then we just do our basic arithmetic. Now this is, of course, generic. This is actually how you would solve every 2 by 2 times a 2 by 3. Ultimately, this is what it would end up looking like. But let's do one with numbers now. All right, guys, so I have a little bit of writing mistakes here. I need to clean these up. All right, so we're doing a sub 2, 1 times b sub 1, 1 and a sub 2, 2 times b sub 2, 1. Let's see, 2, 1, 1, 2, 2, 2, 2, 2, 2, 1, 1, 3, 2, 2, 2, 3. All right. If you would, look at your middle terms here. 1 and 1, 2 and 2, 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 1 and 1, 2 and 2. That's actually coming off of this idea right here, where these numbers are the same. And then you're going to be left with these numbers